Here we're going to take a look at calculating percentage abundances, and we've got a question here where we've been told that the isotopes of chlorine have got a mass number of 37 and 35. We're told the relative atomic mass is 35.5, and from this we should be able to calculate the percentage abundance of the two isotopes. Now, it's all based on this equation here, and it is one that you need to remember, not one that you'll be given, where the AR is the sum of the mass times the abundance of all the isotopes divided by the total abundance. And in this question, we're given the percentage abundance, so the total abundance must equal 100, and that means that all these abundances here on this top line must add up to 100. So if we fill in the information that we've got into this equation, we get the following. We know that the AR is 35.5, and that is equal to the mass times the abundance, and it is these abundances that we're trying to work out. So we've got a mass of 35, and that's multiplied by the abundance, which we don't know, and we're going to call that X. Therefore, that's going to be plus, and the sum of the abundances, remember, must add up to 100. So if this is X, then this must be 37 times 100 minus X, because as we've said, this number and this number add up to 100. And that then is divided by the total abundance, because as I said, we're dealing here with a percentage, and this number is 100. Now, that is how you'd set up this sort of question. And then it is just an issue of solving for X. Now, what I'm just going to copy this for a sec. So if I copy this, what we end up doing then is to get from, what we need to do next is we need to get rid of this 100. And we do that, get rid of the 100 here, by the way. We need to get rid of that 100, and we do that by multiplying both sides by 100. So if I multiply both sides by 100, I get rid of that. And then obviously we do 35.5 times 100. That then becomes 3,550. And that's equal then to all that. And then it's just a case of then opening the brackets. So we do 3,550 equals 35x plus, well, 37 times 100 is 3,700 minus 37x. And then it is just a case of collecting your terms. Collect the x's on one side, the non-x's on the other. So that becomes 3,550 minus 3,700 equals 35x minus 37x. And that then becomes minus 150 equals minus 2x, and therefore if we divide both sides by minus 2, then x equals 75. So that tells me then that my chlorine 35 isotope, remember that is the one which was equal to x here, that must have an abundance of 75%, and my chlorine 37 has an abundance of 25%. So that would be the answer to that particular question. Now, we're going to move on to a different one now. It says this time we've got three isotopes of magnesium with mass numbers of 24, 25 and 26. I'm told the percentage abundance of the magnesium is 11% and the AR of magnesium is 24.3, and I need to calculate the percentage abundance of the other two isotopes. Again, it's based on using the equation given there, and let's fill in the information that we've got. The AR is 24.3. That's equal to the sum of the mass times the abundance. Again, because we're dealing with percentages, this total abundance here must add up to 100, and all the abundances on the top line again must add up to 100. So the information I've got is, I know that the magnesium 26 is 11%, so I can straight away do 26 mass times abundance, plus, now again, we're going to say that the 24, again, we don't know what the abundance of the magnesium 24 is. I'm going to call this X plus 25. Now, in order for the abundances to add up to 100, this now must be 89 minus X. Okay, so the key thing is that all these three here must add up to 100. And then obviously that's going to be divided by 100 because, again, we're dealing with percentage abundances. And again, it's the same principle as before. We would simply multiply both sides by 100. So I'll just copy this. So if we multiply both sides by 100, we get rid of this 100 on the bottom line, which is basically what I want to do. And we need to multiply that 24.3 by 100. And when we do that, we get 2,430. And then it is a case of just solving this for X. So 2,430 then equals 26 times 11 is, I think it's 286. Plus 24x, and then we need to multiply this bracket out. Now 25 times 89 is 225. 2,225, my mistake, minus 25 times x is 25 times minus x is minus 25x. And then it is a case of, again, collecting your terms. So 2,430 then, minus 286, minus 2,225 equals 24x minus 25x. And when we do this sum here, you end up with minus 81. That's equal to then minus x, divided both sides by minus 1. Then x is equal to 81. Now the x is obviously talking about the abundance of the 24 magnesium isotopes, so the Mg24 then is equal to obviously 81%. We already know that the magnesium 26 isotope is 11%, and therefore the magnesium 25 isotope must be 8% in order for them all to add up to 100. And that therefore is my answer to this particular question. We'll do one last one, and hopefully by the time we've done this one, we should be fine with this sort of question. Now I'm given three isotopes of strontium 86, 87 and 88. I've been told that the strontium 87 and 88 are have got the same abundance. They're in the 1-to-1 ratio. They've got the same abundance, and the AR of strontium is 87.7. Again, I've written the equation down that we need, and then we can fill in the information that we've got. So the AR, I've been told, is 87.7. That's equal to mass times abundance. So again, we don't know what these abundances are, but I'm going to call this then X. I'm just going to move this down a line, give me a bit more space. And that's going to be plus. Now we know that the abundance of the 87 and 86 isotope are the same, so I can call the 87 one equal to X as well, because we know that they're going to be the same, plus 88. And again, these abundances have got to add up to 100, so that's now going to be 100 minus 2 lots of x. So that's going to be 100 minus 2x. So again, the key is that all these have got to add up to 100. And that's obviously all going to be divided by 100. So I think in these sort of questions, the most difficult part is probably setting up this here. And once we can do this, we should be able to solve this for x. Again, it's going to be exactly the same principle as we did before. I'm going to just copy this. and we're going to multiply both sides by 100, and in doing so it gets rid of this 100 on the bottom line. So multiply this side by 100, get rid of that 100, and then this then turns into 8,770. So I'll just add that there, move my equals over. And again, now I'm solving this for x. So let's just very quickly do that. So 8,770 equals 86x plus 87x plus, well, 88 times 100 is 8,800 minus 88 times 2x, which is minus 176x. And again, now it's just a case of collecting terms, all the x's on one side, all the non-x's on the other. So I'll get 8,770 minus 8,800 equals 86x plus 87x minus 176x. So what we get there then is, this is minus 30. And when we add up the right hand side, we actually get minus 3x. And if we divide both sides by minus 3, x then equals 10. So what does that tell me then? It tells me that the strontium-86 is obviously 10%, and we know that the strontium-87 is the same. That must be therefore 10%, and the strontium-88 is 8%. So you can see there from this calculation that these are both 10, therefore 100 minus 2 times 10 is 80, and that is the answer to that one. Now, regarding calculations involving percentage abundances, if you can do these three, then you should be ready for anything that the exam throws up.